Hello and welcome to Dunia's Alchemy. This is a GCSE chemistry lesson on ionic, covalent and metallic properties. We're going to have a look at each bonding, how it looks and their properties, along with some exam questions right at the end of the video. So make sure you give those questions a go. Without further ado, let's begin. Ionic compounds or ionic structures are made up of positive metal ions and negative non-metal ions. And as you can see, they're alternating. So you have positive, negative, all in a what we call a lattice structure, which basically means it's regular. Covalent compounds, there's two types. The first one is called simple molecules. And as the name suggests, simple, they're just made up of a few atoms. Examples are water and carbon dioxide. And the other type is giant covalent structures, also known as macromolecular. So look at the word macro, meaning the opposite of micro. So these are giant, meaning they're made up of millions and millions of atoms. Examples are diamond and graphite. There's also silicon dioxide, but I've just left diamond and graphite over here for now. And the last one is called metallic bonding. And as the name suggests, it's made up only of metals. As you can see from the key below it, there are positive metal ions and negative delocalized electrons. Now, if you were to compare that to your ionic, you can see that it also has a positive metal ion. But in place of a negative non-metal ion, metallic bonding has negative delocalized electrons. We're now going to look at the properties of ionic compounds. Firstly, they have a high melting and boiling point. And the reason for that is because lots of energy is required to overcome what we call strong electrostatic forces of attraction. This word electrostatic is really important. Make sure you add that in your exams. Electrostatic means the forces of attraction between positive and negative. In our case over here, it's positive metal ion and negative non-metal ion. So you need to have a lot of energy to break that apart. Second thing is that it does not conduct electricity when it's solid. So when you look at that structure over here, that's not going to conduct electricity, because in order to conduct electricity, the ions have to be free to move. This structure does not look like it's free to move. However, if you were to melt it down or dissolve it in water, then the ions are now free to move and carry charge. So ionic compounds will not conduct electricity when they're solid, but they will when they're molten or aqueous. Covalent compounds, so you have simple molecules. The properties are low melting and boiling point. Reason being, little energy is needed to overcome the weak intermolecular forces of attraction. So the word intermolecular means between molecules. What's holding those molecules together are very weak forces of attraction, and that's why it has a low melting and boiling point. Another thing is that it does not conduct electricity, so there are no free ions or electrons. When it comes to giant covalent structures, the properties are that they have a high melting and boiling point. Lots of energy is required to break many strong covalent bonds. They do not conduct electricity, except graphite. So diamond does not conduct electricity, silicon dioxide does not conduct electricity, but graphite is the only exception that does in covalent structures, okay? And the reason for that is because graphite has delocalized electrons. It has those free electrons between the layers, and they can actually carry charge. Last but not least is the properties of metallic bonding. Firstly, they have high melting and boiling points, meaning lots of energy is required to overcome the electrostatic forces of attraction. So electrostatic forces of attraction are mentioned in metallic and in ionic bonding. Does conduct electricity? We know metals conduct electricity. The reason why is that the electrons are free to move and carry charge. So as promised, I've left some practice questions over here on bonding. Give these a go. They're very similar to things that have come up in exams before. It's about 32 marks, so I've given it 32 minutes. Feel free to pause the video, subscribe if you haven't yet, and good luck. I'm going to let the video roll and the answers will come up shortly, so make sure to pause it. Here are your answers. Again, make sure to check these in a different colour pen, add in your corrections as well. Let me know what score you got out of 32 in the comments, and I'll see you in the next one. That is our video complete. We have gone over ionic bonding, covalent bonding, and metallic bonding along with their properties, and we have also done some exam practice questions. Remember and make sure to do the 3-2-1, share it with 3 others, give it 2 clicks, like and subscribe, and leave a comment. Have a great one.